Hello my dear students. So today's our topic is that is the solution of plane polarized wave and the relationship between electric field vector and magnetic field vector. So in the previous lecture we have studied that if a wave is propagating in x direction, plane wave, then electric field vector is in y direction and magnetic field is in z direction. Means electric field and magnetic field vectors are in a direction perpendicular to the direction of propagation of wave, and they are also perpendicular to each other. Clear? So at the last we have that the equation that we have, we know that the solution of mechanical waves, that is a double derivative of y curly dx square minus 1 over c square y over t square. This is a solution of that. And in the article that electromagnetic waves in a medium having finite permeability, finite permittivity, but sigma is equal to 0, we have del square, yes, that is E upon dx square minus 1 over c square upon t square, that is equal to 0. Clear? And if we have saying that if a wave is propagating in x direction, and electric field is in y direction, we have electric field vector in y direction component of, and component of magnetic field vector is in z direction. We have proved in the previous article that electromagnetic waves are transverse in nature. There is no longitudinal component. Okay? So in that way we can write here Ey. Similarly, in case of this magnetic field, we can write this. Clear? So now we know that C. What is C in the case of electromagnetic waves? That is under root mu epsilon in a medium. And if we have a vacuum or air, this is mu naught epsilon naught, and then at times C is equal to 3 × 10⁸ meter per second. This we have also proved. Now these are the wave equations for a plane polarized wave in the case of electromagnetic waves. Now the solution of these waves, we know that in the case of mechanical waves the differential form is this, and in the case of electromagnetic waves the differential form is this. Now compare this with this. All are same, only instead of y here Ey and hz. So in the same way, the solution of this we have write that y is equal to a e raised to power iota omega t minus kx. Clear? We have write this was the solution. Now in the same way, instead of y we have Ey is equal to amplitude of maximum, means this is maximum value of displacement. Here we take the maximum value of electric field. E naught e raised to power iota omega t minus kx. Similarly, hz is equal to h naught e raised to power iota omega t minus kx. So this will be the solutions. Clear? So now we have the solutions where omega is the angular frequency, k is the wave number, or if in vector form we take it wave vector. So these are the solutions. Now if you want to find out a relationship between electric field and magnetic field, how we can find out the relation between electric field and magnetic field? Now we are proceeding towards the relation between electric field vector and magnetic field vector. ठीक है जी? Or also between, you can say, E vector and H vector. How can you find out the relationship between them? So in the last, we know that we have done in the previous article that if a wave is in x direction, electric field is in y direction and magnetic field is in z direction. So from that we can say that they have in phase each other. They are in phase each other, but their oscillations are perpendicular to each other and perpendicular to the direction of propagation of the wave. Clear? Now, in the last previous article, we have, when we done del cross E, that is equal to minus d by dt of that is B, and instead of B we put minus mu h, and then we take the this in a determinant form, I j k d by dx d by curly d by dy curly d by dz, then e x ey ez. After that we have compare the components of I cap, j cap and k cap, and then we put in that we have got three equations, and we in the same way we get three equations in terms of del cross h. Then we put Ex is equal to 0 and Hx is equal to 0 in that equations. After that some type of these types of equations we get. So you can go, if you go to detail of this, you can go to my previous article, watch that, then you can get it. So I write directly. So we have this type of relation between electric field vector and magnetic field vector using the results from the previous article, this result. Yes beta, from this you can say that this is the result between the space variation of electric field and time variation of magnetic field. Okay? So this, in this relation we put these forms. We have the value of Ey, the solution of wave equation, value of Hz. When we put this value in this equation, what you get? Derivative of Ey with respect to x. So that is E naught, e raised to power is same. Clear ji? Then we can put here, what you can put here? Yes, the derivative of this thing with respect to x. So with respect to x means minus iota k, minus iota k, minus iota k. Got it? Then this is equal to minus mu derivative of hz with respect to t. Derivative of this with respect to t. Yes, with respect to t means h naught e raised to power iota omega t minus kx. Yes, iota omega, derivative of this with respect to t, that is iota omega, iota minus sign. This minus goes with this iota goes with this. What you get? We get E naught e raised to power iota omega t minus kx, or you can also cut it. If you want to cut it, you can cut, or otherwise if think that we cut it. Then we have E naught k, that is equal to mu omega h naught. This we have. From this you can find out the ratio of E naught and E naught by h naught. So E naught by h naught, E naught over h naught, that is equal to mu omega by k, and what is omega by k? If you want to put 2 pi nu over 2 pi by lambda, this is equal to 2 pi nu by 2 pi into lambda. Nu pi goes with nu pi, this is equal to v. Okay? So you can put here v, velocity of a wave, so this is v. Okay? Now we know that in a medium, in the case of electromagnetic wave, v is equal to under root of mu epsilon for a medium, where mu is the permeability of the medium and epsilon is the permittivity of the medium. Put the value mu upon under root mu epsilon, and this will be equal to under root mu over epsilon. 1 minus 1 by 2 is mu 1 by 2. So we get this. Clearly? Now from this you can find out, if you want to find out for a medium, if we know the value of mu and epsilon for a medium, then we can find out the ratio of E naught and H naught. And now if we have vacuum or air, then mu is equal to mu naught and epsilon is equal to epsilon naught. So put E naught over H naught. Now I multiply this by e raised to power iota omega t that we have cut. Okay, upon e raised to power iota omega t minus kx, and this is equal to under root mu naught over epsilon naught. Okay, and mu naught we know that 4 pi into 10 raised to power minus 7, and this is equal to units, you know, Henry per meter, and this is Farad per meter, and also 8.854 into 10 raised power minus 12, you know it. And when you divide these equations, we get approximate 377, and this is EY and this is HZ. You can write it. So from this you can say that the electric field vector, that is equal to 370 times the magnetic field vector. Okay? It means which vector is stronger? Electric field vector is stronger. So that's why in most of the cases we prefer electric field vector instead of magnetic field vector, because electric field vector is 377 times the magnetic field vector. Now what about the units of EY? What is EY over HZ? Just simply अब देखिए the units of electric field vector, that is volt per meter, and HZ, that is ampere per meter. ठीक है, meter goes with meter, so we have volt per ampere, volt per ampere. ठीक है जी, volt per ampere, V is equal to IR. ठीक है जी, volt per ampere, that is R, so units will be ohm. ठीक है जी, so we will do this in the next articles, that ratio of electric field vector and magnetic field vector, that is also equal to this, but also it is the impedance. ठीक है, units are of resistance ना, so we will do that, the ratio is a impedance. We will do this in the next upcoming articles. So thank you very much. So this is very important topic, the relation between E and H and solution of wave equation. Thank you.